What a beautiful day in Yerevan. We have a substitute teacher right now. Vasily, who was supposed to give a talk, unfortunately injured his leg on the way here, so he needs to lay down. And I'm sure he's with us through internet. Vaisa, we're wishing you the best health so that you can run again. Some of us have a possibility to run to the office, and so we're hoping to work more and work together with the people. So the substitute teacher will talk about, we'll continue the previous talk. We'll talk about QUIC and HTTP 3. Please get your questions ready, and whoever's with us through the internet, please join us through Telegram and use the hashtag question to ask Nick questions. Nick Shadrin. I'll be back in 40 minutes.
All right. See you soon. Very cool. It's such a pleasure to be here because this is my first in-person event after almost 3 years of being remote, and I'm really happy to be here with the high-load team. These events are usually the most interesting and most well-organized events, and being a part of that is always a pleasure. And I'll give a little bit of an introduction about myself, and then we'll talk about the subject matter, which is the protocols of HTTP. Now, my name is Nick Shadrin, and even in Russia, people know me as Nick. So that's the case now, and it's been pretty much all of my professional life, the work with the internet systems, the web, HTTP protocols, and such and such. In the last 8 years, I was working for NGINX, and when I joined, there was less than a dozen people in America and less than 30 people total in the world in 2014. So I started as one of the first sales engineers in the company, and quickly went into product management. Back in 2017, together with Igor and Valentin, we launched an NGINX unit. That's the application server, that's the web and application server that's fully dynamic. And now I'm busy with the software architecture. Software architecture of mostly the control plane solutions. This is when you have a lot of different web servers, systems of all kinds, and then you need to centrally manage them, orchestrate some larger environments, and so on. So yes, there is my Telegram account right there. If you need to contact me, or you can find me at nick@nginx.com, or just Google my name. I'm very Googleable. Okay, so today's conversation is about HTTP 3 and QUIC. And what we're going to talk briefly about is the history of protocols of HTTP, and the main differences of how the protocols are different from one another, and how we are upgrading from one protocol to another. We have a very clean understanding that the upgrade to HTTP 3 is going to be significantly more complicated and significantly lengthier process than what we had for HTTP 2 or any other versions before. As far as functionality of QUIC and HTTP 3, we will be talking about the difference in transport protocol, that is being UDP. There is a huge question about encryption, about how TLS is working there, and that's a big difference how it's working in UDP and in the protocol. And another important feature is that connection ID functionality and the distributed nature of how we can work through those datagram in one connection. As far as the real-world implementation, that's a serious topic, and in many cases it has a lot of unknowns. There is a lot of unknowns there because not all of us are using HTTP 3 today. And of course, Q&A. Please do prepare your questions. You can ask questions about HTTP protocols of any kind. Also, questions about NGINX are welcome as well, because this is the only one talk from NGINX here at this conference. Okay. A quick show of hands. Who is using HTTP 3 today in your environments? Yes, we have 1, 2, very few people, and this is great. This is very interesting. Okay, so now we're going to go back to a little bit of the basics, into the basis of the HTTP 1 and 2, and then we're going to evolve the conversation into how HTTP 3 got formed and created. And the basics of the protocol that you can see on this slide, they stay the same around all the HTTP protocols. You have the request, you got the response, you have the HTTP methods, URLs, header definitions, header values, the body, if you have it in the body of the request, the body of the response. But the thing is, HTTP 3 is not changing that. It is not changing those semantics. HTTP 3 is keeping the same semantics, but it is placing them in a different transport, and it's not that simple as it sounds. Okay, so how do we work in the different transport across the protocols, and how we were doing that across the last 30 years? The very beginning of that was the HTTP, what we now call version 0.9. If you open telnet to a port 80 of a website which does support that protocol, for example, just go to nginx.org and you just do telnet nginx.org port 80, and you just do capital get/ and press enter, you will receive something. In some cases, you will receive a response from a CDN or somewhere else to say that version is not supported, or just no, please don't use HTTP 0.9. But some websites, and NGINX in its pure form, it does support it. It gives you back the content. But there was no more headers, no more ways to manage that connectivity, to tell the server to do something else other than just give you the default page. So HTTP version 1 was created with the functionality of headers and different other features, such as different options for managing the methods, the contents, upgrades, and so on and so forth. HTTP 1.1 actually was the one that added more features for HTTP headers and ways of controlling the connection. The thing about HTTP 1 and HTTP 1.1 for that same reason was that it was only using one TCP connection for one piece of content. For example, if you have a page with CSS files, JavaScripts, and all kinds of other things, only one object was per connection. How does the browser usually work with that? The browser, by default, opens five or six connections in parallel, and trying to get all the different parts of content at the same time using that number of TCP ports and that different TCP connections. This is nice in theory, but in real world there were some limitations to that. Opening too many TCP connections, this slowed down some of our network equipment and web servers as well. So one of the things that got invented around 2012, 2013 was the project by Google called SPDY. It was called SPDY, or SPDY. And that was the project where Google tried to put different requests, HTTP requests, inside of one TCP connection. That way, it was possible to utilize more of the bandwidth of the network, more of the TCP bandwidth. The thing the thing where where SPDY evolved to was the standardization of SPDY into HTTP 2 protocol. And HTTP 2 protocol is a little bit different from SPDY. It is using the different encryption or different methods of compression for HTTP headers. And also there were things in HTTP 2 related to its negotiation. We'll talk about the protocol negotiation in a lot of detail later in this presentation. So the things about HTTP 2, it got quite a bit of adoption, but that adoption was quite slow. There were several issues with HTTP 2 where it was not performing well for networks with a lot of jitter and packet loss. It actually turned out that if you have high packet loss, using multiple HTTP 1 connection was actually better than using one HTTP 2 connection. for the ideal networks in terms of packet loss, but the networks with a high latency. If your ping is like 400 milliseconds, but you have good connectivity of all the packets reaching the destination, in that case, HTTP2 was doing really well. That was one of the cases. And the other cases where HTTP2 was doing really well is when you have a lot of smaller objects on the web page. For example, if you have just one HTML, one CSS, one JavaScript, there is not much difference. But if you have 100 little pictures and 20 CSS files that can be compressed well, and then you're using another 50 API requests to build your page, then there is difference. In that case, HTTP2 was performing really well because for each of those little requests, you now did not need to reestablish the connection and do all the negotiation. You were able to use the same TCP connection and just use the different streams inside of that TCP connection in order to make the HTTP requests. So once again, one TCP connection, many streams inside that TCP connection, and one HTTP request per that stream, but all of the low-level network optimization was working on one TCP connection. Okay, so from the network standpoint, from the viewpoint of the low-level network devices, there was no difference, not much difference, in handling port 443 with HTTP2 or HTTP1. That was still the same kind of port and the same kind of connectivity, the same kind of low-level optimization in the boxes, in the devices on the way. In HTTP3, there is quite a bit of difference. We already well know, it is well known that we are using UDP transport instead of TCP transport in order to use HTTP3 or QUIC for the same reason. Now, in this case, that's one of the big differences is the change of transport. Okay, so what's interesting about UDP? One of the things that we need to talk about is that UDP is handled basically the same way across the different operating systems. It is way lower level method of passing packets through the network. And since it is a lower level method of passing packets, now we need to build all of that higher level functionality further up into the protocol. So if we go back one slide, you can take a look and you see that TCP has a layer, and on top of TCP there is another layer with a TLS. And only then on top of TLS we get the HTTP protocol. In QUIC, the big difference is that we need to implement the encryption features within the QUIC protocol. Okay, somebody might ask a question, why do I need encryption if most of my content is cat pictures on the internet and nothing else? For some reason, in the HTTP2, there was a decision made by the browser vendors not to support plain text versions of HTTP2. And the same vision continued with HTTP3 with even more attention to encryption. So encryption got way into the protocol. There is no way to get out of that. With HTTP2, there was a way to create a plain text HTTP2 connection. The plain text worked from the concept of client and server, but realistic browsers like Chrome, Firefox, and others would not support that. The browsers didn't want that. Some people are saying that it was because of the advertisement companies about some were talking about spoofing of plain text connections and so on. But I cannot fully comment on that. It's kind of the decision of different organizations on doing that way. Okay, so let's see it in the comparison of the stacks here. In HTTP1, TLS and encryption of all kind, it was also optional. And when you're using curl, when you're just getting the page of some sort, you get the data directly, and it is readable. With HTTP2, now we have the streams that are all kinds of binary data. Now it is also encrypted, but it is still working on TCP. So the question here is, how are we going to look into that HTTP2 protocol? We had to start using different tooling, and things like curl, the web browser developer tools and others, they had to be updated around the time frame of 2015 to 2017 in order to support that works of HTTP2 protocol. They got updated well, it is working now, but it was a long and painful process to get that done through all the variety of operating systems that we're using. Okay, so here's now we're at the same kind of question again of updating our tooling in order to now read HTTP 3, just the same as we were doing that for HTTP 2. Cool. Let's take at another interesting picture. So in the front end of this nice diagram, we're looking at the support of HTTP 1, HTTP 2, 3, whatever other extensions and things you might be doing on the front end of your network. The very, very front, which is where you're connecting to something like NGINX or other servers. But on the back end, do you really need HTTP 2 or HTTP 3 when you're looking at the back end of the things? And we found that in the realistic environments, the backend HTTP 2 was not very. There was not much demand for the backend. In the backend, usually you have a very nice high-quality network, so latency is not a question. In the backend, you're looking at doing specific requests to the specific servers instead of having a variety of picture requests where you don't care which picture is going to be downloaded better and so on. So backend actually turned out to not be very demanding to the challenges that we were just discussing on the very front end of the things. So backend is HTTP 1. And here's another interesting fact. If you have HTTP 2 or HTTP 3 or both or whatever in front of your network, please don't ever turn off HTTP 1, well, HTTP 1.1 in this case. Okay, fun fact. Google search engine pessimizes web pages if they don't have HTTP 2 support. It likes when the page has HTTP 2 support, it likes those websites more, it elevates them. It goes down, your website is going down if you're not using HTTP 2 and only using HTTP 1. Now the punchline. In order to scrape those sites, Google uses HTTP 1. Yes. I did that experiment once. I turned off HTTP 1 on my website. It basically disappeared from the search engines. I had absolutely no bot traffic. If you want, the previous talk was about DDoS attacks. If you want to get rid of the DDoS attacks, turn off HTTP 1, but you will also lose the search traffic. Or some other clients, if you have not the browsers, but some programmatic clients which will still use HTTP 1. So yes, it's up to you. It's up to you to turn it off or on. I can see a lot of smiling faces here, but these words don't turn off HTTP 1. Those are most realistic. If this is the only thing that you're getting outside of this presentation, is this one. Okay, let's go a little bit further into the benefits of HTTP 3 now. And you will tell me if those are actually benefits. First one is that since we're using UDP transport and we're implementing the features of encryption and congestion control and all kinds of other things in the application level, we have less reliance on kernel. Why does that matter? It matters if you have if you manage the clients and servers, both of those things by yourself, not just the servers but also the clients. In some cases, using HTTP 1 and HTTP 2, you are unable to create the piece of client software because it will be looking at TCP stack that is still using the old operating system there. It will use the kernel features of TCP stack, and you cannot change those. Those are still the same regardless of what you want to do on the application level. However, in HTTP 3, if you're creating the server and the client, in the client you can do all things that you like and still use Windows XP or whatever. UDP is supported the same way. Is that a good thing or a bad thing? it can be actually a bad thing as well, because since you're relying less on the kernel, you have to build more things yourself. It's more work. And the question is, are you going to do it better than people already did with the 30 years of TCP development, or 40 years? Yeah, a lot of smart people were making TCP, so it works pretty well. Are you going to do a better job? I believe that some of you will, but maybe not everybody. We'll see. Okay, the next question that you might think of as a benefit here is the built-in encryption in that protocol. And one of the good things about building encryption inside of that protocol is you can take it outside and have a different encryption style from your normal OpenSSL, normal TLS, or other things around your machine. Maybe that's a good thing. Where it can be not the best of the things is if you're doing it yourself and you're building your own boring SSL or LibreSSL or QUIC TLS or whatever other library, you have to look at that one in addition to your OpenSSL. So one question is, are we expecting more SSL and encryption vulnerabilities in the world? Yes, we're always expecting them. They always happen. And if you're using HTTP3, you have one more encryption library to worry about. Maybe it is better, because maybe that one is going to be better than your normal OpenSSL, but maybe not. We don't know. This is the future we're talking about. Next functionality, which is very important, is called the connection ID. In a very layman's terms, there is a bunch of datagrams going into your server, and we don't have to look at the IP addresses to combine those datagrams into logical connections. But we're looking at the thing called connection ID in order to combine them into the logical piece. That basically means, and let me put it this way, in theory, in the most theoretical terms, if I'm taking this phone and I'm trying to access a web page, some of my traffic might go through my 5G connection, some of it might go through Wi-Fi, and maybe I'm walking around and changing my IP addresses all the time. In theory, this should work with HTTP3 without breaking the logical connection. Is it working today like that right now? I'm actually not sure. Is it something that's going to be working in future? I really hope, because being in an elevator and changing my connection to 5G and getting out of elevator into a different Wi-Fi point and still be able to maintain logical connectivity to the server is a very promising idea. Okay, so this is a great feature. And another one, which is an interesting benefit, is the faster negotiation of that HTTP protocol. So the faster negotiation is an interesting question. We'll cover that here right now. So how do we negotiate HTTP protocols? There are different ways of doing that, and I'm looking at the first one as the very simple method of negotiating from the non-encrypted HTTP into encrypted HTTP. There are methods to do that within the protocol or even within the web page itself using the HTML tags or JavaScript functions as well. This is basically well known, 301 redirect or 302, whatever. You can do that easily. Next one is HTTP unencrypted into HTTPS negotiation is using the strict transport security headers. If you're familiar with those, this is a method to tell your browser to not look at unencrypted website at all, and to remember for a long, long time, like 1 year or so, that your website only works by HTTPS, and you shouldn't use an unencrypted connection to that site. How well this is not the strict convention. Some browser might lose that header. Some browsers might think that they need to clear it for whatever reason. People use new browsers, and also the programmatic clients that you're building, they might not use it at all. So even though it's called strict transport security, it's actually not that strict. The next type of negotiating of the protocols is HTTP upgrade. HTTP upgrade is a special HTTP convention where the most usable thing is how you are upgrading the standard HTTP connection into a WebSocket. This is also well known, but in order for us to upgrade into a different protocol, you first need to establish connection with the previous protocol. And this is where we're going into the different methods of negotiating a protocol between HTTP 1 and HTTP 2. The first and very kind of easy and logical way of negotiating that protocol into HTTP 2 is to use the upgrade header. Basically, you tell the server that you're supporting that protocol. The server is giving you the 100 continue and so forth. But the thing is, you're talking too much over HTTP 1 before you're starting sending content over HTTP 2. For that reason, there were different methods of connection negotiation created between those protocols. And one of those was called NPN, Next Protocol Negotiation, and also ALPN. Both of them are extensions to TLS. Okay, now let's go back a little bit into how we defined HTTP2. It has TLS connectivity. It can be encrypted. It can also be unencrypted, but people don't like it. If HTTP2 is properly encrypted, well, the only method of negotiation of HTTP2 that was adopted by browsers such as Chrome, Firefox, and whatever is ALPN. ALPN is very simple in that basically you are sending your initial packet to the server, and with that packet you're saying that you can accept HTTP1 and HTTP2 connections, and server starts responding immediately with the keys. If you had the pre-shared sessions and whatever, you immediately get the content coming back straight up without extra hops to go back and forth to negotiate the protocol. So basically, you're sending your protocol knowledge immediately as you're connecting to the server, and that's in this case. HTTP2 inside of those ALPN, it's called H2, just a lowercase h and the 2. If you're doing some Wireshark troubleshooting, you will see those H1, H2, and whatever just inside of your TLS extensions. Okay, all of that doesn't work with HTTP3. It doesn't work at all because we have to not only negotiate the ways of how we are sending that traffic, but also change the method of transportation of that traffic. And that method of transportation now is UDP instead of TCP. You have to go to some different type of connection establishment. And for that idea, the thing that got standardized is the alt service header, ALTSVC, that thing. Right here I show just 3 examples. And those are very interesting in this case. The first one is maybe one of the most used ones that you will see here. It is where it is actually working for HTTP2 just as much as HTTP3 as well. So that got standardized not only for HTTP3 but for other protocols as well. And in this case, we're defining the host name and the port, and the max age parameter. The MA stands for max age. This is the time in seconds for that time your browser or your client is supposed to remember that you have that type of connectivity available in order to perform the faster negotiation in the subsequent further requests later and later. In the second example, where we see H3, then that website with a different port, there is another very interesting example. We're using different port. Okay, and in the third one, we are defining it without the host name, which means connect to the same thing using the different port. Does it have to be the different port? Well, in most cases, you will be using HTTP3 on the same port 443, like you're using with the normal kind of HTTP 1 or HTTP2 connection. But for any other things or reasons, you might want to use it on a different port. whatever suits your specific environment. Does it make sense? Probably not, because those UDP ports might be blocked. Okay, this is the page which you might take a picture of, because I was told that I only have 10 minutes left, and I'm going to be skipping through. No, I have 15 minutes. I just got 5 minutes more out of that. That's great. So yes, we can stop on this picture and discuss the security features as well a little bit better. All right. So in this case, we're showing the full kind of negotiation of the protocol. Remember my previous slide, I said HTTP 3 provides faster negotiation. Does this look faster? Yes, it doesn't. This is why we have the next slide, where we kind of called it the optimistic negotiation. Basically, some clients, some browsers might want to send the TCP request and also the UDP request at the same time to this, and this clicker is dead. I'll just be doing this, and you'll skip to the next one. Okay, so the faster negotiation is supposed to be working, but it is not specifically the convention. It's called the prior. Some people call it the prior knowledge protocol negotiation as well. Okay. Let's get to the concept of the real-world environments. This is what we were discussing up to this point. We were talking about the client talking to your server. You have both of those ends very well known. Everything is great. This is not the real world. The real world is probably looking like this, but really, the real world. Come on, let's. Okay, so real world is looking more like that. Those boxes in between the client and the server are not necessarily the ones that you know and own. The previous speaker from Curator owns a couple of those boxes. Cloudflare might own another couple of boxes. Something there might be your application firewall. Maybe there is a load balancer. Maybe there is some kind of other things in between. Even down to the switches and routers of the providers. You don't have the client connecting to your server. You have the client connecting to a load of boxes, and only then one of those boxes will be connecting to your server. And all of that support of different HTTP protocols needs to be either properly implemented in between or totally ignored in between. Which is better, we will know later, because the thing is, there is that kind of scale between the usability and security. If you want everything to be absolutely secure, you need to decrypt everything on every step. All of those vendors will want to dig into every bit of your traffic and every logical piece of your traffic. Doesn't really work in terms of performance. Doesn't really work in terms of usability in some cases. But the total ignorance to the traffic also doesn't work. Okay, so somewhere in between is the real world. Some of those boxes right now, they know that traffic well. Some of them don't know it well. But this is why I was saying that that the migration process into HTTP 3 is going to take a little bit longer than it took for HTTP 2. There is more to worry about, and this is why the talks about implementing HTTP 3 were going on for several years right now, and it is still not fully implemented by many of you. There was just a couple of hands there with the people who had it going. Okay, there is another piece of challenges, and this is more the piece of challenge for us as the developer for NGINX and other companies like us who are developing HTTP 3 support for our software or for F5 hardware or whatever other things. And one of those is that UDP stack is not as optimized as TCP. This sounds a little bit counterintuitive, because TCP is supposed to be slower than UDP, but there was so much effort over the last decades into optimizing TCP. Its optimization was actually done really well. And UDP, once we are starting to implement features of UDP performance into the protocol and back into the application, all that work hasn't been fully done by anybody. So it's not it might not be just as optimized as TCP. With TCP, you have the legacy things. With HTTP 3 and UDP, you don't have that legacy. And not having that legacy means you can implement newer features in there, use newer kernels, newer low-level hardware functionality and whatnot. But it still needs to be done. Next, it's the multiprocessing functionality. If we go deeper into the web server mechanics, there are multiple processes there. And normally, UDP packets, they're going all over those processes. We need to recombine them, use some kernel features sometimes, but this is a lot of questions there. Making UDP transport for a web application was not an easy task. We did pretty much all the work already with NGINX. I'll talk about that in a moment, but there is still a couple of things that need to be done. Another question that I already touched on was the tooling challenges. And the lack of plain text version and the minimal debugging features is another kind of problem there. One of the examples, okay, let's say you take the Chrome browser and you start working with some HTTP 3 website and something breaks somewhere in the middle. Your browser will go back to HTTP 2, HTTP 1, back into TCP, and it will say, okay, that UDP doesn't work. I'm going to forget about that this website works with HTTP 3, and I will go down to HTTP 2 and 1 and not use HTTP 3 at all. How to get your browser to use that HTTP 3 back, how to get it back on track. This works for a developer. There is an option for Chrome, for example, to force the use of HTTP 3 on a specific domain name. But for all of your customers, that's another question. You lose a little bit of your HTTP 3 connectivity. All of your network basically goes to HTTP 2. Some of them will come back, some will not. There will be a mix of protocols. Or for you, looking at HTTP 3, you realistically cannot look at that as the protocol that's going to work 100% of the time with 100% of your users. It will not. It will work with some percentage of your users. Hopefully, it will work with a large percentage of your users. But how much, we don't know. This is going to be specific for your project. Okay. The previous talk was mentioning some things about security, DDoS attacks, and some other things. And I absolutely agree with this previous speaker. Yes, UDP is not very trusted. Remember that who was here at the previous talk? We have quite a few people. There was a huge slide there which was saying, what's the workaround for this attack? Turn off UDP. Turn off UDP at which level? Well, whichever level you're turning off UDP on, you're losing all of your HTTP 3 connectivity at all. Is that a solution? Well, for some things, like if you're getting a DDoS attack, you're turning off UDP, and now you're getting rid of a DDoS attack. But if your network was so much optimized that you cannot actually handle TCP there, you just turned off UDP and you got the DDoS attack back by your own users. So please think about it when you're sizing your systems. This thing about UDP, it's not a silver bullet in performance. You still have to be able to maintain that TCP connectivity back. There is a number of different attacks there, and probably I would speak to some specific security companies on that. There is also some conspiracy theories about that protocol. I'm not going to touch on those, about how Google owns too much of protocol development, but basically those are nice protocols. Okay. And another point that is very important, it's the agility of the protocol. I heard this today, this morning. Somebody said, I'm a bit chaotic, but let's say I'm agile. To make a lot of changes with a piece of software, and especially with the protocols, it's hard for all of those devices in between your server and your client to support all of those changes and all of that agility of the protocol. So basically, you need to wait, in many cases, you need to wait for the protocol to be more stable in order to be implementing that in the environment. Okay, the question was, what are we doing with NGINX right now? We have a separate branch. Just go to quic.nginx.org, and right there you will have a how-to on how to install it, how to get that branch, how to compile it, and what to do next. And soon we're going to have it in mainline. But here's a huge kind of slow down. Remember, I was talking about security features being the part of the protocol. So the thing is, OpenSSL APIs and OpenSSL functionality is not allowing us to build a QUIC and HTTP3 on top of OpenSSL easy. There is no way of doing that. And right now, the only way we are supporting HTTP3 in NGINX is using it with boring SSL. Okay, so boring SSL, that thing doesn't exist in pretty much all of the mainstream operating systems as a standard package. You have to find it yourself, compile it yourself, make it yourself, and that means that you will be first compiling and installing the library, and then you will be installing that special NGINX with the HTTP3 module that will be linked to that library. We are against including encryption features inside of NGINX. It is technically possible to compile a static version of NGINX with all the encryption features, but it will change the product and it will change the life cycle and your response to the security vulnerabilities because in our view, encryption should be separate from the web server software. This is one of the reasons why it is really hard for us to just do the mainline release with HTTP3 features because of that security encryption and the security and encryption functionality and boring SSL not being the part of normal packages. Okay. When you are configuring NGINX for HTTP1, this is pretty simple. Listen 443 SSL, that is fine. With HTTP2, pretty much all of your NGINX versions, if you don't have the HTTP2 parameter in your listen directive, this is pretty safe. This is pretty safe and well known. And with HTTP3, we get a little bit more to do. We need to add the alt service header right there, and we need to create another listener for that HTTP3 protocol. This is going to be in addition to the normal TCP listener. So that's a bit of a difference in configuration. And once again, this doesn't work with stock NGINX today, as of December 2022, and it will be working with a special branch, and soon enough you will see it in mainline, but not today. All right. So we're getting here further to the end of the presentation, and one of the main premises here is that HTTP1 is not going away; it's still there. HTTP2 it is basically the standard for normal kind of devices and protocols, and HTTP3 is still upcoming, even though we've seen that for several reasons, for several years. Another thing to look at right here. This is definitely a must-read. And this is basically one of my last slides. I want to give the opportunity to let's ask the first question while this slide is on this is right here, because this is definitely the must-read. This book explains in a very simple terms and in a lot of very good in good words on how HTTP3 works and why. I fully recommend that one. Okay, let's listen to the first question.
Yes, because you cannot stop talking on this topic. It's a non-ending conversation. If you have a question, please. Yes.
Okay, thank you. Coming back 1 hour ago, how does QUIC or HTTP3 handle something like TCP SYN flood?
Well, HTTP3 or QUIC is not related to SYN flood attack. It is the different level. If we would be looking at those layers if we would be looking at the layers that like the OSI diagram or whatnot, the SYN flood is one level below HTTP1 or HTTP2. It's 3 or whatever. This is one level below, no difference.
Well, but HTTP3 handles negotiation like TCP. Are there some built-ins that mitigate that, or how does UDP kernel stack?
Got it. Yes, we don't have any specific answer to that. No, we don't have any specials on this. Sorry.
Any other questions? Yes, please.
First of all, thank you for interesting talk. So, as far as I know, there are no handshake mechanism in UDP, right? So, how the IP verification is done in HTTP3?
It is not.
So I can arbitrarily send any IP I want, or
Basically, the main idea there is the connection ID that is common inside of the protocol. But in the ideal world, your traffic can be coming from the different IPs, but still be the same kind of logical content.
so basically I can generate as many IPs, fake IPs as possible with HTTP3. Did I understand you correctly?
The problem will be in responding to those, but yes.
Okay.
So is this the
Okay.
same question or?
Yes. Yeah.
So you just answered this question. Any other questions? In the back, yes. While we're handling the microphone, there's during Moscow High Load, there was a team of young boys who forked NGINX and are distributing it for the Russian market. Do you have any relations, and how do you feel about that happening?
The question about forking NGINX is a very important one for the world of open source. And anybody in this room or any country or anywhere else can fork NGINX, and some people are doing that. One good example is OpenResty, and that was done by Yishuan Zhang, and this is a very good example of a successful NGINX fork. Another good example is T-Engine that was done by Taobao in China. Very nice one, but it got a little bit out of support right now. I didn't hear much about them. And the guys from Moscow did a very recent fork called NG. Very nice work from them. Some part of that team, they're coming from original NGINX, and we're really happy that they're continuing to work in the industry and in the web servers. They're basically, it's better, and it's a great thing for community that they're working in the software that is very like NGINX, and they are contributing very good code to the community. If you have some legal restrictions, you might be using their software instead of American F5 software, or American F5 NGINX software instead of theirs. It is also providing a lot of flexibility, especially for the companies who are limited in their ways of purchasing software.
Okay, thank you. And the final question.
Thanks a lot, Ignas Bogdanas. And apparently our lovely host just overtook exactly the same question that I wanted to ask myself. It's about the fragmentation of NGINX environment, if any at all, especially in the context of OpenResty, NG, and other forks, right? So that's answered, question is taken away.
Yes, but you mentioned another thing about fragmentation. So the thing about fragmentation, the developers from NG, they mentioned that they want to be as close to NGINX mainline as possible for as long as possible. And this is the correct way of collaborating in the software like that. It's better for us to be maintaining a closer the closer code base between those projects and forks, and be able to exchange the greatness of the new code for the benefit of all of the community. And whichever one you're choosing to use, this is basically your choice for the very specific details of your project.
Thank you, Nick. Those were beautiful 45 minutes. So Nick, a good round of applause. Nick will be in the discussion zone, so you can continue the talk in any language you choose. We need to pick who gets the white developer's hat for the best question.
Yes, this is a very good point there, because the question about fragmentation, it was definitely very interesting. But I don't think I can give the prize to the same members of program committee, who's going to be giving out the prize to one another.
He says no.
So we're going to choose the question there that is I did like a lot the question about this the security attacks, right? I forgot the face right here. Yep, here you are.
You could wave to the helpers so that they could give you the present.
Yep.
Nice. Sweet. So please rate the talk for us to have true feedback. And the next talk is here in a few minutes. I think it's 3:50. Yes, in 20 minutes we will talk about video streaming with a speaker from Yandex.
Uh-huh.